Okay, so next and very important topic, that is the Legendre linear equation. The next topic is Legendre linear equation, or you can say Legendre linear differential equation. Okay, so what is the Legendre's equation? So an equation of the form, we define the Legendre linear equation. An equation of the form, equation of the form, which form? Write the equation a naught ax plus b raised to n d raised to ny by dx raised to n, and plus a1 ax plus b raised to n minus 1 and d raised to n minus 1 y by dx raised to n minus 1, and plus a2 ax plus b raised to n minus 2 and d raised to n minus 2 y by dx raised to n minus 2, and plus so on up to a n y and equal to x. Okay, name this equation number 1. Is called the Legendre linear equation, called the Legendre's linear equation, okay, or you can say Legendre linear differential equation, Legendre linear differential equation, okay, and where a naught a1 a2 up to a n are constants, and x is a function of x only. X is a function of x only. Okay. Now see here. If the right hand side x equal to 0, then equation number 1 become homogeneous Legendre linear differential equation. Okay, this is the non-homogeneous Legendre linear differential equation. Okay, if right hand side is non-zero, then that will become non-homogeneous Legendre linear differential equation. If right hand side is 0, then this is homogeneous Legendre linear differential equation. Okay, and how to solve the Legendre differential equation? So we will see the method. The method is known as what? Method of substitution. Okay, so method of substitution. Method of substitution. Okay, this is a very simple method. So we put ax plus b equal to e raised to z. See here, in Cauchy homogeneous linear differential equation, we putting x equal to e raised to z, but in Legendre homogeneous linear differential equation, we put ax plus b equal to e raised to z. The technique is same. So this can be written as z equal to log of ax plus b. Okay, and we write what we write. same, ax plus b dy by dx equal to a dy. So here we write same as like a Cauchy homogeneous linear differential equation, but here a constant a, here constant a is multiplied with x, so that's why we're writing here a. Okay, and for second term, ax plus b square d square y by dx square, and this equal to, we write a square d minus 1 y. Okay, for dq, ax plus bq and dqy by dxq, and this equal to, we write aq d minus 1 and d minus 2y. Okay, and so on and so on. In general term, if you write, so you will get general term ax plus b raised to n d raised to n y by dx raised to n. So this equal to, we write here a raised to n d minus 1 d minus 2 d minus 3 and so on, so on. In the last term, that is d minus n plus 1 y. Okay, so in this way we write, if there is first order derivative, then we write a dy. If there is second order derivative with coefficient, then we write a square d d minus 1 and y, and so on up to nth order derivative. Okay, so by substituting all this value in equation number 1, then equation number 1 reduced to, then
सर वो आपने लिखा है D-N+1 लिखा है।
हाँ यही है।
सर आपने वो आपने लिखा है ए, वो है ना d² y/dx² का D-1 लास्ट में है ना, मतलब D-1 स्क्वायर था तो -1 है, मतलब 1 आया,
हाँ
मतलब तो इसमें n+1 कैसे हो गया, मतलब एक ज्यादा हो गया ना पावर से।
नहीं भाई, देखो यहाँ पे, देखो इधर इधर ऑब्जर्व करें, यहाँ पे देखो, यहाँ पे 2 था, ठीक है, तो यहाँ पे कितना आया, 1 आया, ठीक है, और 1 आया कैसा, -1 आया यहाँ पे, और यहाँ पे 3 है तो यहाँ पे -2 आया, यहाँ पे n है तो यहाँ पे कितना आएगा, n-1 आएगा ना, तो n-1 आएगा, ठीक है, और माइनस साइन यहाँ पे आगे है तो ये -n हो गया और ये माइनस माइनस से प्लस हो गया, तो इसलिए मैंने ऐसा लिखा है। समझ में आया ये, समझ में आया क्या? हाँ ठीक है, okay. Now if you substituting all this value in equation number 1, then equation number 1 reduced to, then equation number 1 reduced to equation 1 reduce to the linear differential equation with constant coefficient, reduced to the linear differential equation with constant coefficient, okay, and we know very well how to solve the linear differential equation with constant coefficient by using 5 types of method and variation of parameters, whichever suitable you can apply. Getting? So now let us do the problem based on this, then you will understand this concept very easily. चलिए example solve the differential equation. We write 1 plus 2x square d square y by dx square minus 6 times of 1 plus 2x dy by dx and plus 16y, and which is equal to 8 times of 1 plus 2x square. Okay, we will solve this differential equation. So before solving, we just copying the given differential equation solution. So write down given differential equation. Given differential equation. So what is the given to you? 1 plus 2x square d square y by dx square minus 6 times of 1 plus 2x dy by dx and plus 16 times of y equal to 8 times of 1 plus 2x square. Okay, so now we will solve this differential equation. So for this what have to do? We put 1 plus 2x equal to how much? E raised to z. Okay, so this gives z equal to log of 1 plus 2x. Okay, so given differential equation is Legendre differential equation. Okay, so for this we putting here 1 plus 2x equal to e raised to z, and we write and we write what we write 1 plus 2x dy by dx equal to what? We write here 2 dy. Here a is what? Here a is 2 and b is 1. So a dy, that is what? That is what? That is 2 dy. And for second term, we will have 1 plus 2x square d square y by dx square. So for this, we will write 2 square d minus 1 y. Okay. Now substitute all these values in equation number star. So given differential equation, name this equation number 1 or star. Okay. Now if you substituting all this equation number, if you substituting all this equation in equation number 1, then equation number 1 reduced to then equation 1 reduced to a linear differential equation with constant coefficient. A linear differential equation with constant coefficient. Constant coefficient. Just write down. Okay. Therefore, we will have instead of this term, that is 1 plus 2x the whole square d square y by dx square, we put this term, that is 2 square d minus 1 y and minus 6 times of, so instead of 1 plus 2x dy by dx, we putting here 2 dy. So write down into 2 dy and plus 16y as it is, 16y as it is, and this equal to 8, or here 1 plus 2x, so 1 plus 2x, we put here e raised to z, so this become what? E raised to 2z, because there is a square. Okay, e raised to 2z. Now just simplify this. So we simplifying, so we write 2 to the 4 d minus 1 y minus 6 to the 12 d y and plus 16y, and this equal to 8 times of e raised to 2z. Okay, now we will take common from each term. Y is a common in each term, so we will take y as a common. So just write down 4d and d minus 1 minus 12 times of d plus 16. Okay, and into y, and this equal to 8 e raised to 2 z. Okay, now simplify the bracket. So we will have,
सर
हाँ
सर इसमें 4 भी अगर कॉमन लेके इस साइड ले जाके काट दे तो 8 को 4 2 जा 8 कर दे।
हाँ यार वो कटेगा, अभी मैं कर रहा हूँ ना, आगे कर रहा हूँ, टेंशन मत लो।
ऑल्सो लेकिन हम लोग ने यहाँ पे 1 + 2x dy by dx को 2 dy क्यों लिया है?
1 प्लस
1 + 2x और dy by dx को 2 dy क्यों लिया है?
इसको देखो, इसको मतलब कैलकुलेशन का बहुत प्रोसीजर है, इसको डिफरेंशिएट करेंगे ना तो हमको यही मिलेगा। ठीक है, तो
अच्छा हाँ डिफरेंस।
हाँ, तो वो सब चीज़ें मैं यहाँ पे नहीं दिखाई शो कर रहा हूँ कि मतलब इस तरह से आपको करना है, तो ये बहुत लेंदी हो जाएगा, तो फिर आप कॉन्सेप्ट को नहीं समझ पाओगे। ठीक है, आपको डेरिवेशन नहीं करना है, आपको प्रॉब्लम सॉल्व करना है। समझ में आए? तो आपको ये, हाँ, स्टेप आपको ये याद रखना है, आपको उसका डेरिवेशन नहीं करना है। मैं हर एक प्रॉब्लम का डेरिवेशन कराने जाऊंगा तो मतलब कि बहुत ही कॉम्प्लिकेटेड होता जाएगा आपके लिए भी और हमारे लिए भी, क्योंकि 1 घंटे में हमको मुश्किल से एक ही प्रॉब्लम हो पाएगा, एक या डेढ़ प्रॉब्लम, तो उतना टाइम नहीं है ना हमको करने के लिए। आपको जो प्रोसीजर बताया जा रहा है, आप जस्ट अप्लाई इट एंड सॉल्व दिस। आपको केवल सॉल्व करना है, सोल्यूशन निकालना है। ठीक है, आपको उसमें रिसर्च नहीं करना है। गेटिंग? यस और नो?
हाँ सर यस
हाँ,
सर।
ये आप खुद के प्रैक्टिस के लिए, अंडरस्टैंडिंग के लिए आप इसको डिराइव कर सकते हो कि कैसे आया, क्यों आया। ठीक है, चलिए हम आगे की बात करते हैं। अब क्या बोले थे, 4 कॉमन निकालने के लिए, चलो मैं आपकी बात मान लेता हूँ। वी टेक कॉमन, we will take 4 as a common from each term, so you will get d d, we multiplying, just wait, now take, uh, we just dividing 4 on both side. Okay, we don't take common, we dividing 4 on both side, so divide this, so you will get d minus 1 minus 3d and plus 4 4 just 16, you will get 4. Okay, and y, and here you will get 4 to z, 2 times of e raised to 2 z. Okay, no need to take common 4. So now multiply d inside the bracket, so you will get d square minus d and minus 3d and plus 4. Okay, into y, and this equal to 2 times of e raised to 2z. Now simplify this, you will get d square minus d minus 3d, so you will get 4 times of d and plus 4 into y, and this equal to 2 times of e raised to 2z. Okay, now we will find the auxiliary equation for this, so we write down, therefore the auxiliary equation is given by, the auxiliary equation is given by, what is the auxiliary equation? We write d square minus 4d and plus 4, and this equal to 0. This is your auxiliary equation. Okay, and what are the roots of this auxiliary equation?
2 2 2
2,
आएगा
2 2 आएगा, because there is a minus sign, so you will get the roots of this auxiliary equation is 2 and 2. If you don't know, just factorize it. Okay, चलो factorize कर देता हूँ. So now find the roots of this auxiliary equation, so you will get d square minus 2d and minus 2d and plus 4. Okay, now just take d as a common in each term, so let us move to the next phase. So we will take d as a common, so d, here d minus 2 and d minus 2, and this equal to 0. So from this you will get d minus 2 and d minus 2 equal to 0. So you will get d equal to 2 and 2 repeated roots, which is repeated roots. Okay, so for the repeated roots you will have the complementary function, therefore the complementary function is given by the complementary function is given by, for repeated roots, yc equal to c1 plus c2z into e raised to 2z. Okay, because 2 repeated 2 times, so here 2 constant will be added. Getting? Now name this equation number 2. Now our job is to find particular integral. Now to find particular integral, pi. Okay, for this we write yp equal to 1 upon d square minus 4d n plus 4. Now the right hand side, what is the right hand side? Your right hand side is 2 times of e raised to 2z, 2 times of e raised to 2z. Okay, now what? Which method you will apply? Just general method, because there is exponential function. Just standard method, not general method. So here we will apply the standard method. Okay, just check whether it is 0 or not. So if I putting here 2, so this gives 2 to the 4 minus 4 to the 8 and plus 4. 4 8 minus 8 0 means you cannot put directly. Okay, so for this, what we have to differentiate denominator. So we multiply z first, then differentiate denominator. So you will get 2d minus 4. Okay, into we write this 2 e raised to 2z as it is. Okay, now put here. Now put, if I putting here 2, so 2 to the 4 and 4 here. 4 minus 4, this will again 0. So this will not work. So for this, what I have to do, we again differentiate denominator and multiply z. So just do this. So multiply by z. So this becomes z square and differentiating with d. So you will get 2. Okay, into 2 e raised to 2z. Okay, and this 2, 2. So this become z square into e raised to 2z. Okay, this is your yp. Name this equation number 3. Therefore the complete solution is given by, the complete solution, or you can say general solution, the complete solution is given by, solution is given by, what is the complete solution? So we write y equal to yc plus yp, and this equal to, your yc is what? Your yc is c1 plus c2 times of z into e raised to 2z and plus z square e raised to 2z. Okay, so now replace the value of z. What is the z here? Z is what? Just write down c1 plus c2. So z we have log of 1 plus 2x, 1 plus 2x. Okay, and into e raised to 2, and just write down log of 1 plus 2x. Okay, and plus this z is what? Log of 1 plus 2x the whole square. Okay, and into e raised to 2 times of log of 1 plus 2x. Okay, now just write down one more step. So this can be written as c1 plus c2 log of 1 plus 2x, 1 plus 2x into, see here, this 2 goes on the power. Okay, so this become what? E raised to log of 1 plus 2x. Okay, but e raised to log of something is something, that is 1 plus 2x square. Getting? And plus, just write down this log of 1 plus 2x the whole square into this is what? E raised to 2 log of 1 plus 2x. This 2 goes on the power. So this become e raised to log of 1 plus 2x the whole square. Okay. So this can be written as simply 1 plus 2x square. So this is your complete solution of given Legendre differential equation. I hope you understood this first problem of Legendre differential equation. Got it?
Yes.
Yes.
So let us do the another problem. Solve example number 2. Solve, we write 1 plus x square d square y by dx square and plus 1 plus x dy by dx and plus y and equal to 2 times of cos log of 1 plus x 1 plus x. Okay, like this we have to solve this differential equation. Solution. So first of all we copy the given differential equation. Just write down given differential equation. What is given to you? 1 plus x square d square y by dx square and plus 1 plus x dy by dx and plus y, and which is equal to 2 times of cos log of 1 plus x. Okay, now name this equation number 1. So this is the Legendre linear differential equation. So for this we will put 1 plus x equal to e raised to z. So this implies that z equal to log of 1 plus x. Okay, and we write what we write? We write 1 plus x dy by dx equal to 1 dy. Okay, see here coefficient of x is 1, so we write here 1. Okay, and the next term 1 plus x square d square y by dx square. So this equal to what? 1 square d minus 1 y. Okay, now substituting all these values in equation number 1. So equation number 1 will reduce to a linear differential equation with constant coefficient. Therefore the equation 1 reduced to a linear differential equation with constant coefficient. Okay, just write down, just replace all these values. So instead of this 1 plus x whole square d square y by dx square, we putting this. So you will have d minus 1 y and plus, so instead of 1 plus x dy by dx, we putting simply dy and plus the last term y as it is, and this equal to 2 times of cos, but instead of log 1 plus x we put here z. So this becomes simply cos z. Okay, now we will see y is a common in each term, so just take y as a common. So we have d minus 1 and plus d and plus 1. Okay, and so d minus 1 this term and plus d and plus 1, are we taking y as a common? So this equal to 2 times of cos z. Just simplify, just multiply inside. So we multiplying d inside the bracket, so this become d square minus d and plus d and plus 1, okay, and into y into y, and this equal to 2 times of cos z, okay. So this d and minus d will cancel, this become d square plus 1 into y, and this is equal to 2 times of cos z, okay. Now write down the auxiliary equation. Therefore the auxiliary equation is given by what are the auxiliary equation? We write d square plus 1 equal to 0. So this implies that you will have d equal to plus minus iota, that is I. Okay? So these are the complex roots. So we write down the complementary function. Therefore the complementary function is given by CF is given by, what is the CF? YC equal to C1 cos Z plus C2 sin Z. Okay, this is your complementary function. Now name this equation number 2. Now our job is to find the particular integral. So just write down the particular integral. So for this we will move to the next page. So to find particular integral, now to find particular integral, that is pi. So for this we write yp equal to 1 upon d square plus 1, and the right hand side, your right hand side is 2 times of cos z. Right hand side is 2 times of cos z. Okay, now substitute the coefficient of cos z. Substitute the coefficient of cos. What is the coefficient of cos? 1. So we write here minus 1 square and plus 1. So this become what? Minus 1 and plus 1. This is 0. So we cannot put directly coefficient. So for this, what I have to do? We first multiply by z on the numerator and differentiating this denominator with respect to d. So this become 2d into 2 cos z. Okay. Now what I have to do? This 2 and this 2. So this equal to z and z by d into cos z. Okay. So this can be written as z integration of, this is 1 upon d cos z. So this can be written as integration of cos z and dz. What is the integration of cos z? What is the integration of cos z? That is sin z. Sin z. Okay. So name this equation number 3. Therefore the complete solution is given by, complete solution is given by what is the complete solution? Y equal to yc plus yp. Now substitute all these values over here. So this become y equal to yc. We found here c1 cos z plus c2 sin z. Okay, this is your yc, or plus yp. Your yp we found z sin z. Okay, now we replacing the value of z. So just replace this value of z. So this become y equal to c1 cos. What is the z? How much we put z?
log 1 plus
Previous,
x.
yes,
Log of 1 plus
log
x.
of 1 plus x. Okay, so instead of z we put log of 1 plus x. Okay, and plus c2 sine log of 1 plus x. Okay, and then next plus z, that is log of 1 प्लस x into sin log of 1 plus x. So which is your required general solution of your given differential equation? Getting? I hope you understood this problem. समझ में आया बच्चों लोग आपको?
Yes, sir.
Yes, sir.
हाँ.
Yes, sir.
Now today we have finished your module number 2 also. Getting? अगर किसी को कुछ भी डाउट या प्रॉब्लम होगा तो बिंदास बेझिझक बिना हेजिटेशन के आप कभी भी और किसी वक्त आप पूछ सकते हो. ठीक है, तो आप ज़रा जो भी एक्सरसाइज और असाइनमेंट दिए हैं उसको प्रैक्टिस कीजिए घर पे और सॉल्व कीजिए और ट्राई टू इम्प्रूव योर स्किल कि प्रॉब्लम किस तरह से सॉल्व किया जाता है, कितने समय के अंदर कैसे हमको सॉल्व करना है. ठीक है.